Let us continue. Page number 6. We reach up to here. E is equal to F upon Q. We say F is the force acting on the test charge and Q is magnitude of the test charge, and that quantity we call electric field. We call it as electric field or intensity of electric field. Both are the same. Intensity means strength. Light is more intensity. Light is less intensity. To understand that, let us continue. Here is the charge Q, can be positive or negative. This is producing an electric influence surrounding that. We want to measure the strength of that at some point. I keep a positive test charge. The charge I call it as test charge. It is testing the presence and strength of an electric field. To distinguish that, original one source charge, the testing one test charge. There are two properties of test charge. It must be positive and it should be small. Why? It is positive reason. If the test charge is always positive, what is the advantage? If the force is repulsive, it is moving. In this case, it is repulsive. So then I know original charge is positive. If the charge were original charge were negative, it would have been a force of attraction. So direction would have been force of attraction towards that. So since it is positive, I will be able to identify nature of the source charge. If it is positive, test charge will be repelled. If it is negative, test charge will be attracted. So it has to be positive. Always be positive. Second point, it must be small. Why it should be small? Imagine the charge is large enough, maybe 2 coulomb, 10 coulomb like that. When you keep the test charge, automatically it will be displaced. If it is positive, repelled away. If it is negative, attracted towards. When I am measuring the electric field, original charge should not be disturbed. No disturbance. So it should not be, that means there won't be any change in the initial conditions. Suppose I keep a very small test charge, maybe charge of an electron, that is negative, charge of proton, positive, I keep it there, it won't be much affected. So, two quantities, the properties of quantities of the test charge must be positive and small. Reason, if the test charge is positive, we know that is, so that automatically I can find that the original charge is positive or negative. Why it should be small? We say the test charge produces its own electric field. What is the meaning? That also will have some electric influence. And it will modify the original electric field. Modify means what? Change the original field. So the result will be the electric field measured will be less than the actual value. The strength we are measuring, then it will be less than the actual value. It is faulty. It should not be possible. Answer is given in page number 7. Give reason why the test charge is small. Test charge is small so that it will not disturb, it will not change, it will not modify the original field. It will measure the actual field. You can go through the give reason. It is clearly mentioned there. Combine. So how to define electric field is F upon Q. What is F? Force acting on the test charge. What is Q? Magnitude of the charge. So can we define what is electric field, or we call it as electric field or electric field intensity. Both are the same. So it is the, simply expand the word. It is a force acting on positive test charge, small positive test charge divided by magnitude of the charge. Repeat. It is a force acting on small positive test charge divided by magnitude of the charge. F is a vector. I put a vector sign. Q is not a vector, it has no direction. So electric field is a vector. E is F upon Q. What will be the unit? Unit of force is Newton. Unit of charge is Coulomb. So we say therefore the unit is Newton per Coulomb. Or we say, we can write this way also, Newton Coulomb inverse. Newton per Coulomb. In the chapter number 2, we will see that another unit that will be volt per meter. Volt upon meter. What is volt? We have not studied, so you don't bother that. Now, chapter 2 we come across, this will be Newton per Coulomb. Don't mix up. This will be in chapter 2. Now, Newton per Coulomb. Electric field and the unit. Then how to find the expression for electric field? To find the expression for electric field, I make use of the same diagram. I am having the test charge Q, electric field between a single charge. Just one step. Everybody can find what is going to be the force between the charges. Force between the charges will be F equal to 1 upon 4 pi epsilon 0 product of the charges. Most of us know Q1 means capital Q, Q2 means small q upon distance between the two, let us say small r upon r square. So this is going to be the force, but what is electric field divided by Q? So I divided by F upon Q, that means I divide the whole thing divided by Q. So no doubt Q and Q cancels. I get 1 upon 4 pi epsilon 0 Q upon r square. So what it stands for? E. So somebody asked what is the expression for electric field? What I will say, I have written here, E is 1 upon 4 pi epsilon 0 Q upon r square. 1 upon 4 pi epsilon 0 Q upon r square. I can use capital Q or small q in the problem. So another equation we introduce. But if it is a vector, how to put the vector sign? So I got 1 upon 4 pi epsilon 0 Q upon r square is going to be our electric field. Now how to get it as a vector? I consider a vector in the direction of r. I write it as r vector. I consider it as an r vector. Then if I am having a unit vector, I write it as r cap. What is r cap? Unit vector pointing in the direction of r, from the charge towards the test charge, from the charge towards the given point. This I call it as a unit vector pointing from the charge away from that, in the direction of r. I multiply by a unit vector. We know unit vector magnitude is 1, it only gives the direction, then automatically it will become a vector. So what is electric field in vector form? 1 upon 4 pi epsilon 0 Q upon r square into r cap. But for the problem, we remember only this way. E is 1 upon 4 pi epsilon 0 Q upon r square. Then what is the direction of electric field due to a positive charge? If I keep a positive test charge here, it will be repelled away because of the positive charge. So is the force is towards the charge or away from the charge? Definitely force will be away from the charge. I clarify that point. So there is vector form, just I mentioned. What is the direction of electric field due to a point charge? It is away from the charge, we will clarify. Example, I am having a charge plus q here, capital Q or small q, anything I use. Where test charge is coming, then I use capital and small q, now anyone. I want to know what is the electric field surrounding that. Consider a point P, I keep a positive test charge, it will be repelled. It is away from a positive charge. I want to find here, join that, keep a positive test charge, it will be repelled away. I keep here, positive test charge, it will be repelled away. Positive test charge, repelled away. What about all these directions? The directions in which positive test charge is repelled away. So I can say direction of E here, direction of E here, direction of E here, direction of E here. So for a positive charge, electric field is away from the charge. It is not towards, away, because repelled. With this as the center, let me draw a circle. Don't you feel the circle? The electric field, the radius is going to be same for the circle. So electric field at this point, at this point, at this point, at this point will be same. Because distance is same, charge is same, so electric field is same. So I can say electric field, this is the radius. I use the language. For a positive charge, electric field is acting along the radius outwards. So we say this is going to be the radius circle. So it can be small q or plus q. Anything is okay like. I write it clearly. Plus q. So here we are. So when we are having a charge q, electric field is plus q radially outwards. I use that language, radially outwards. So what is the direction of electric field due to a positive charge? It is radially outwards. So or it is away from the charge. Most of us will be able to follow. What will be electric field due to a negative charge? What will be electric field due to a negative charge? I rub it off and clarify. I am having a charge q, let us say small q or capital Q, minus q. How to find the electric field at a point? I want to find electric field at this point. What I will do? I'll keep a positive test charge. Will it be here? Will it be attracted or repelled? Attracted. So what is the direction of the force? Attraction. What is the direction of the electric field? Towards the charge. Let me keep another one here. Anywhere we can keep, no doubt. What is the direction of the electric field? Towards that direction of the electric field. I keep here. I can keep anywhere. I keep a positive test charge. It will be attracted. That is the direction of electric field. Direction of the electric field. Then I keep it here. Definitely, it will be attracted. So I can see electric field into a negative charge. It is towards the charge. Or we can say, with this as the center, if I draw a circle, with this as the center, I draw a circle. Then what will be the electric field? Instead of radially outwards, it will be radially inwards. It is radially inwards. So our point of discussion, what is mean by electric field? It is F upon Q. Then what is the magnitude? Is Newton per Coulomb. The unit is Newton per Coulomb. Then what is the expression? 1 upon 4 pi epsilon 0 Q upon R square. What is the direction? It is radially outwards for positive charge and radially inwards for negative charge. We continue with this part next time. Till then, bye.